I'm going to rotate this. When I rotate it, I do get a signal EMF of like this, where B will be less than, so D will be less than C, C will be less than B, B will be less than A. This is called like a fundamental. And these are all called as harmonics, odd harmonics. Usually odd harmonics, all these are called as harmonics here. Like this, you have to continue. How many N harmonics will be generated? So when you try to plot actually how the signal will be. So once again, I'm telling this one. Yeah. So this is what we made the problem very simple by just assuming what is a sine omega t. Let me show that thick line. This is what the fundamental. Remaining all will be now. How do they come? So this will be 3 omega t. So by the time this completes one cycle, 3 cycles will get over. 3 cycles means you can show it here. How the graph will be. 3 cycles means 1.5 should come here. Next again, I'll show by different colors. I take different colors. Next, 5 omega t. 5 omega t means 5 cycles. It should get over. 5 cycles means 2.5 will come here. 1, 2, then this one. Like that, what happen? You keep on draw that one. No? Like this, these are the harmonics. This is called like a fundamental. You have to be very careful. Questions can be asked here. This is what actually the EMF induced. When you rotate a loop, no, we'll get fundamental harmonic. But what is needed? The only fundamental is what needed for application. These are unwanted harmonics, unwanted harmonics. So what I do, I'll use a filter. So using a filter, like how in when we prepare tea, no, after tea got boiled properly. So what we should do with the dust, tea dust, it should be taken out, no. So for that, we'll bring a mesh like this. This is called like a filter where the tea will come out and the dust will settle here. Similarly, electrical filters are there. So what they permit set of frequencies, they permit other set of, they block other set of frequencies. I'll design in such a way that only frequencies correspond, only signals corresponding to angular frequency omega should be permitted. Remaining all will be blocked here. Then we'll get a pure sine wave that will be transmitted. Again, during transmission, again, what when the harmonics will get added up. This is what happens in the transmission of AC signal. So definitely you can see that why we are getting noise. There's a Zoom class, no? Some students will say, if you look at my recording, there won't be noise. But when you are listening class, there is a noise. Tell me why it happened. Because when the signal getting transmitted, the noise will get added up. And then what is the noise? Noise is the AC signal. Unwanted signal like this of arbitrary frequency that will get added up at all parts of the circuit. In my mic, in the wire connecting from mic to laptop, or that one, headphones, again in the laptop, at all parts, what happen at all points in electrical electronic circuit, the noise will get added up. So why the Zoom is, you can say you can say wonder, that one, because they have designed the software in such a way that it will eliminate noise at all parts. And we have discussed the same thing in class MS Teams. Lot of noise was there, no? It was not designed properly. Only in the laptop they've designed, but when it get transmitted and the receiving end, they didn't bother about for that particular thing. That one. So why Zoom classes are almost noiseless means because of this one. So still I am getting noise at my end, then it's your mobile and your connectivity problem. Not with the Zoom software, that one, but the Zoom software will try its level best. And compared to all what happened, the Zoom software is designed in such a way that it will eliminate this noise. It will eliminate harmonics were all generated, because this is what actually I'm speaking. Noise is unwanted one. Even the microphone, what it will do, it will generate my sound signal and harmonics. So again, what when the Zoom software will eliminate this. It's a very complicated, I'm telling you this one. You become electrical electronic engineer, no? So the one who will trouble you for your whole life, professional life, the noise. Your entire designing of circuit is eliminating this noise here. So just I'll wind up because we can't spend much time on this. Possibility of asking in exam, wanted is the fundamental, unwanted is harmonics here. Everywhere it will be generated. Whenever you generate any signed AC signal, no? So the harmonics is unwanted will get generated here. This is what actually happens in Faraday's law. The Faraday, what happened, he was troubled by more by this. How do these harmonics has come? Because he has to justify. He could not explain further. Later, electrical technology got improved. Then what happened? They were able to give explanation for this. See, I think what we discussed is only 10% of Faraday's law. The remaining this we didn't explain. Why only this? So what all EMI chapter is what we have just studied only 10%. Okay, don't scold your teacher because the syllabus confined only to this particular thing. That's why I skipped it. Actually, we have to give this also reason. So it's very quite complicated. So the mathematics or what all we know, no? Electrodynamics you have to enter there. With the help of that, you can manage here. So I'm confining. So they may give signal of this kind. Now next we'll go for if it is having both AC as well as DC signal. So let me look at that one. What is A plus B sine omega t? So let's just construct these signals now. There's a value of A, no? Then B sine omega t. So it will fluctuate about this value. So shall I say it's a, the value is A and A plus B. I'm showing the signal. So I think in trigonometry you might have come across. If you add DC to AC signal, no, it will get shifted up here. So then there's a signal. Now such a signal, now if I send only current A, then there's a DC emitter. So what it will read? It will read A. If a AC emitter, I'll send only this signal, B sine omega t. What AC emitter will read? It will read B by root 2, no? Reading of this. And the reading of DC emitter will be, IDC will be A. What about IAC? Will be B by root 2. Now let me send this composite signal where both DC emitter as well as AC emitter is present. Now I am going to ask you, what is the reading of both the meters? Okay, I just took a example. If I send a current of magnitude equal to A, the DC emitter will read that equal to A. If I send current of B sine omega t across AC emitter, it will read RMS value of it because it is so designed. The AC emitter is so designed that the deflection produced by that should be proportional to each generated. So therefore it will read RMS value of it, B by root 2. So let me send this composite signal. So what is the composite signal? DC plus AC. And let me connect both in series. So which meter will read what value? That's what the question I'm asking. So first we'll calculate the reading of AC ammeter. How to calculate a reading of this? I think we know already enough mathematics. I'll proceed with this. RMS square is equal to I square dt. The composite signal is what we are showing. So they may mix up with sine, the triangular wave and the DC signal. You should be ready for all such kind. Here I took sine wave and DC signal. DC signal, sine wave. They can mix up. So let's expand this one. So 1 by t. Integral of dt in the numerator will become 1 by t. 0 to t. A plus b sine omega t whole square dt. take now this one. So the expansion of this will be a square dt. I'll write directly the steps. This will be b square by 2 integral of 1 minus cos 2 omega t dt plus 2ab try to see the expansion. A square plus b square sine square omega t plus 2ab sine omega t. I'll break up in this way here now. Flower bracket, I'll put it here. No, so let's solve further. See, I think there's no concept. Everything, the basic math should be applied very systematically. That's what this topic demands. A square t. This should be only b square t. Cos 2 omega t in one full cycle will be 0. So we'll end up b square t. Then 2ab, this term should be 0, no? And this will be 0. Integral of cos 2 omega t dt. There's everything in the bracket. This value some other, I'll highlight it because the entire bracket term, this one is what equal to only t. I'll show that in bracket. It'll be easy for you now. Okay, fine. Now you see how much we are ending up. The t will get cancelled. So finally, this RMS square. So what should be the value of this? A square plus b square by 2. Or if I write it in more systematic way, a square plus b by root 2 whole square. What is a? The DC value. So, sir, you only said AC ammeter. Will it read DC value? See, the ammeter don't know anything, no, what all current flows. It will be generated proportional to that. E to what happen? It has to produce the display, the deflection. So the reading of what is RMS? Reading of AC ammeter. So what is the reading of? This is the reading of, or high AC if you write it. If you want to write it high AC. Now this much is there. So there are 2 meters are there. There's a reading of AC ammeter. What is the reading of DC ammeter? High DC. I'll write it in corner here. Reading of DC ammeter. It will read average value. No? What is the average value of sine function? In one full will be 0. It will read only A. The DC ammeter will read A. What is the average value of B sine omega t? Will be 0. This should be equal to only A. So the DC ammeter, what it will read? Average value of a given function. DC ammeter will read sir, how you can say average value of this A plus B sine omega t is only A? I think you know all of you how to calculate average. I average is equal to 0 to t, A plus B sine omega t. So we'll do one thing. If you are finding really very difficult, You're not going to square it, no, you're going to keep it. Nothing conceptual, everything with mathematical we are going to analyze. You see everything, this will become a t integral of dt. There's a reading of IDC. Let me write here. So small I will use. So finally, how much will end up? Equal to A. Justified. This will be 0. This whole quantity will end up to 0. So therefore, if a circuit having both, so like if a composite signal, DC and AC signal flowing in a branch, and their DC emitter connected will read average value. AC emitter will read only its RMS value of AC signal, nothing. The AC emitter, because the AC emitter, I'll come back to that. This one, the AC emitter, what happened? Don't put it this way logically. The AC emitter will read RMS value of this. DC emitter will read only this. No, the AC emitter, what happened? Will the total A plus B sine omega t will flow, no, and this total